Hello, so welcome back to another live stream. So I'm supposed to build this AI model now, and we will start with the dataset. So let me open up Xkelly and give you some basic idea about what I'm about to do. Okay, just a second. So building an AI model takes a few steps that I told you in the last video. Let's go over them again. Just give me 1 minute. Let's begin. So first, the step is getting the training data set. Then the next step is to we can say data processing. Very few simple steps. Then after data processing, we do we set the training parameters. Then we finally train the model. And then we simply deploy it. So on a surface level, this is the high level understanding of building an AI model. Let me just check if I'm visible. My screen is visible. My camera is turned off. Okay, great. So this is the process. This is the whole, life cycle of building an AI model. Now, there can be many additional steps according to, what level of AI model we are building. And for the ML ops, we just run through the cycle again and again, like we get new data by data mining and everything. Then this whole process runs uh, again and again, and we constantly monitor, the performance of our AI model. Okay, so there are some additional steps, like we can say in getting the training data set, there are, multiple pieces. For example, if we have insufficient training data, okay, let's say this is the case, this is the challenge that we are facing. So we don't have enough training data in the format that we want, which is the format that I have told you, the task, the task and subtask format. So there is not enough data that is available to, directly uh, mine and use it in our use case. So this was the first challenge that I had to face. So there are few processes by which we can dynamically generate the training data as we need. So we need to start with a few examples. Okay, so we need to have some examples. Then, uh, this is a manual process, manual data building. Okay, and once we have these examples, you can say, uh, the more the data we have, the better it is. But let's say I have 30 to 50 data points. Okay, and now what I have to do, there is this thing called data augmentation. Okay, so this is the challenge, this is the solution. Now what data augmentation does is it basically takes the data that we have, for example, these 30 to 50 data points that we manually had to write, then it, rotates and flips the data around the words and the task and subtasks to, create the random data set using the data that we have provided. Okay, for example, if I have given this one data point here, for, I can say the task is to create a website, and then the subtasks are, mm, you know, design the layout, create a layout in HTML, style the website. So, for example, I have given this one data set, a manual data that I have written by myself. I give this to, data augmentation process. Now, what data augmentation does is it flips around everything, like it creates variations of this data point here. For example, it can change the order of these tasks, maybe change a few words, maybe relate one data point to another or something. Like it basically flips around the data and it create unique copies of the same data that we provide to it. Okay, so by using this 30 to 50 data point, it basically create any number of copies that we want. For example, if I want to generate 5,000 data points, I can simply generate these by data augmentation only if I have like 30 to 50 data points. So this is great, but overall the quality and accuracy of the AI model like goes exponentially down. Okay, so the more the data, basically this degrades the data set quality, because I only have 30 to 50 data points and I am just generating different copies of the same data by randomizing the order of the words and the subtasks. So this generates data, 5,000 points I will have, but it will not have, the good quality that I need. So for now, I'm just, keeping it up to here. I will just use these data with low quality just to train the model. Maybe later on I will find some resource or something where I can get the data, or maybe I will write more examples to create better data set. Okay, for now we will use this data augmentation to get the generate the data. I will share the format of the data and the data sets that I have with you in just a moment. And then data processing, again, just like the last time, we can divide it into two parts: pre-processing and post-processing. We don't need post-processing here. We will just stick to the pre-processing. And in pre-processing, basically what we are going to do, let me just rearrange these. Okay, so in data pre-processing, we will majorly do three things. First, format the data correctly for training. Then we are going to split our data into two parts for training and testing. Usually, people, you know, split it into three parts for training, testing, and monitoring. But we are going to split it in just two parts. For training, we are going to keep the 90% of the data and 10% for the testing, because we have less data set to train upon. That's why usually people keep it to 80% and 20%. But we are going to use these. Okay, then you will define the training parameters. Like how do we want our model to be trained? Like there are few parameters, not few, but a lot of parameter like epochs, and I can't recall it, but top K something. I don't remember actually, and I don't even know also all the parameters. Now the training part. Okay. Now the training we will do in Go Labs. Actually not Go Labs. It is Google Colabs. Let me just recheck it. I don't remember. Yeah, Google Colab. We will train the model here because I do have enough resources to train the model on my system, but it will take a lot of time. And Google Colabs provides us with free resources to train our model, so I'm going to use this. This is fast and free. What else do we need, right? Then finally, the deployment part where we, convert our API model into API endpoints. We basically expose our AI model to the API endpoint so it can be accessed through, other applications or other services, you can say. So yeah, this is going to be the flow for our AI training. Okay, so let's start with the data. For the data set, I have, 30 examples in the format like this: task, and then subtasks. This is just an array of the steps. Okay, and this is just a big JSON file. Okay, this is the data. I basically use ChatGPT and some of my examples to curate the list of these 30 examples. Then this part I have already done. This is already done. And after that, let's move to data augmentation, where we are basically going to write the script to generate a data set from these examples. We are going to generate 5,000 data points. Okay, so first of all, just a prerequisites. Okay, we need Python, obviously. We are going to use Anaconda to, set up the virtual environment and everything. Then we are going to use Jupyter notebooks. I already told you why we are going to use this, because when we run a Python file, whenever we, make a change and then run that again, it basically reloads the model and everything. Then everything starts from the beginning. But in Jupyter Notebooks, we basically have cells. And for example, if we have run this cell here and we are on this cell, so uh, we are actually, if we are here on this cell and we change something from here, then we do not need to run the application from here from the start. We can just basically rerun the application from this part, because all the below must be dependent on this cell. Okay, so if once we have this code that loads the AI model, we do not need to run that code again and again, because loading the AI model takes quite a lot of time. Yeah, basically, it's just a better approach for development. Okay, so let's start. Okay, let me just create a folder, Bright AI. Now I want to create an environment in Conda. So I don't remember the command actually. Create environment. Yeah, Conda create name, and name should be AI train environment and Jupyter. Okay, let's go through this blog. Yeah, basically we set up this, then we create environment. Yeah, it's actually Conda. Then we active environment basically. Active AI train. Sorry, Conda activate AI train. We do not have the environment here. Okay. Conda create name, and let's create the environment for AI models as that. Yep. And now let's activate it. Conda activate AI model. Okay. Let's create the, so my bad. Let's create a directory called source, and inside that, let's create a directory called data.org. I suck with these names, so please bear it with me. Okay. Now we have the environment setup. Okay. Oh, actually, I don't need to open the VS Code. I just need to create a new Jupyter notebook. So I do I need to install this again? Okay. So I've created a notebook with the name generate dataset. So let's bring in the raw data first. So let's come here. I have this raw data here. So this works. These are, this is the- these are like 30 examples of manually generated code. So starting with the example, we need to import two libraries, random and JSON. Then we need to import the code with open for data. We open it in read mode as F, and then we samples subtasks. Okay, not subtask actually. Basically, I want to convert this data in the format like uh, I want the format to be something like this. I want to have uh, an array with the name task categories, which basically contains all the tasks. Then I want subtask dictionary, which contains the task, then the mapped subtasks. So first I will generate this uh, subtask dictionary. Just a second, I have for this. Right. So this is how I want my data to be. So the for now, our data is in the format like we have this, then there is this task, and we have subtasks, which is just an array, a list of all these subtasks. So we want to convert our data into task categories and subtask dictionary. Okay. So basically, we will convert this data into subtask dictionary format like this, and then we can simply extract the keys from here to create the task categories. So our first step is to format or data. Okay, let's convert it into this format. Let's see. Let's do raw data set equals to JSON dot loads. Right. Okay, raw data dot JSON. Is it load? Yep. So let's see what our what data set looks like. So let's just see one example here. Okay, this is how it looks like, as I've told you. Now, now that we have the raw data set, we need to format format the raw data set. Let's convert this to Where is that markdown cell? Cut cell, split, merge above, code, markdown. Yeah. Now we need to format the raw data set. So basically, we need to map this task to this array of subtasks. Okay. So let's loop over raw or task in our data set. We will create a samples dictionary, and then for data task in raw data set, we are going to use the samples dictionary, and the task, we want the task as the key, and its value is going to be task subtask tasks. Okay, let's see. Ran successfully, I think. Let's check our sample dictionary. Okay, so print sample dictionary. Okay, exactly what we wanted. So this is our formatted data. Now the data is formatted. We are going to use this data now. So we have this sample dict, and we also wanted the task categories. So for task categories, we need a list of sample dict dot keys. Okay, sorry, sample dict, samples dict. Now if we print the first category, yeah, we are getting it right. Okay, so now we have our samples dictionary and task categories. So we can start with our data augmentation. Okay, so let's define a function called create task entry, which basically creates a task entry and defines the subtasks for it. So let's create subtasks, which is going to be subtasks dict. Actually, this should be not sample disk, but subtasks. Okay, let's change that here, that here, that here also. Okay, we need to run this again from the beginning. So it's not defined. Wait, what? Subtasks dict is not defined. Okay, subtask dict. Okay. Yeah. So okay, so okay, this is to restart the kernel. I How do I like run the code? Okay, I will just hit shift enter. Okay, great. Now subtasks is going to be for this particular task entry. It is going to be subtasks dict, and we are going to get the task that we are going to put here, and then an empty list. Now okay, my bad. Okay, so we are going to attach complexity and priority to each subtask. Complexity, define complexity and priority to each subtask. Basically, we are going to create a detailed subtask here and subtask actually. And here we are going to have this object which contains the description, which is the subtask, and the complexity is going to be random choice from. We are going to have three types of complexity: low, medium, and high. Okay, so we are just basically flipping data around, doing a random choice on the complexity. Then in priority, we are going to do the same random choice for low, medium, and high. Okay, just give me 1 second. Now, now to get this subtask, we are going to create a for loop here, which basically returns the subtask in a random sample of subtasks, and we are defining the k value, which is going to be minimum of length of these subtasks and a value between a random value basically integer value between 5 and length of the subtasks. Okay, and finally we are going to yeah, and finally we are going to return the format again, task, which will contain the task and these subtasks, which is going to contain the detailed subtasks. Okay, let's see priority and valid syntax. Okay, great. Now this is the function to create the task entry. So let me add a cell, insert a cell below. Let's move it up, and this is going to be marked on. function to create a single rotated task entry. I Okay. And similarly, we are going to create another function to generate data set with parameters, with number of samples actually. Okay, so let's define another function called generate dataset, which will take a parameter of num samples, and here we are going to create a list called dataset, and we are going to run loop for the range of num samples, the number of samples that we want to generate that we provide in the function. And basically what it does is it creates a single entry of task by randomly choosing a task from the task categories. Then it basically appends the randomly generated task into uh, in the data set. So this is a single task which is chosen from the task categories. Now we want the generated task, task and subtask basically. Task, subtask I can say, or generated data point I'll say. And we are going to use this function create single, sorry, create task entry. Ah. And we are going to provide the task here. Now finally in the data set we are going to append this generated data point. Okay, and finally we are going to return the data set. That's all for this blog. Now for the data set, let's say generate the data set. Okay, and we will use 5,000 samples, 5,000 samples of data set, and for that we will create this data set list, which is basically going to call this function generate data set with 5,000 as the value, and let's run it. Let's see. Okay, so problem is here. Sample method object is not subscriptable. Okay, let's see. For subtask in random dot sample subtasks K is minimum in the length of some task. Then we provide not random integer between 5 and length of the subtasks. Okay, looks right to me. Okay, how can I miss this? There is some option to run all the blocks below it. Where is that option? Cell, gen all cells below. Okay, same error, unhashable type list. Okay, let's see. Great. Okay, so let's take a break for 5 minutes. Okay, back. Now just let me check if we have this data set with me. So let's print it out. Data set and just okay. So we have the task and the subtask with detailed subtask. Okay, that's how it should look like. Right. Now that we are done with the formatting and generating the dataset, let's move to uh, you know, importing like actual model training here. Okay. Me that because these are not important at all. Just for a better notebook. Great. Now comes now actually not the model training. Now it's the time for data preparation. Okay. Actually, I was thinking if I should, generate the data set and train the model here itself. But it will be better if I export this data set and use a separate notebook for model training. Okay. So let's say export the data set and let's do with open data set JSON, right, as file. Okay. And then we do json.dump the data set and the file pointer, and we want to indent the JSON with 4 spaces. Okay. Finally, we want to print generated samples, or we can say data set dot length of data set. Actually, I forget all these methods in Python. I need a refresher now and then. Okay, so generated this much of data set task set. Okay, let's go. Generated 5,000 tasks in dataset, and let's see. Okay, this is another folder. We have this data set.json, right? Do I need to, create a folder here? Maybe I should put the data set here. Yeah, no, it's fine. Whatever. Okay, so we are done with this notebook now. Let's go back to home page, source, and let's create another folder, model train. I will probably refactor all of this, so don't worry about it. Okay, so inside the model train, we to create a Python 3 notebook, and we are going to name it model training. Okay, so in Python notebook, just a second. Okay, so in Jupyter Notebook, we need this exclamation mark to run terminal commands. So we are going to use pip3 install, and we need torch and pandas, transformers, datasets, and sklearn. Okay, this problem. Okay, this is not sklearn. We just need transformers, datasets, torch, and scikit-learn. Now it's done successfully. Let's import all of this. We need torch, then we need to import JSON, pandas as PD, and from transformers library, we need to import T5 organizer. Then we need T5 for conditional generation. Then we also need the trainer, and we need training arguments. Okay, that's all that we need from the transformers. Okay, this bad habit of me pressing the shift and enter, always run these cells. And in the data sets, we need to import data set and load metric. Then we need scalar dot model selection. And from that, we need to import train test split to split our data. Okay, now let's see. Import torch. No module found. How? Satisfied, already satisfied. Okay, all of these got installed, but none of them are getting imported. Why? We just restart this kernel. Start and run all. Yeah, already satisfied. Scikit. Yeah, we import this and let's print out the system environment. Yeah, let's reinstall our packages like this in the same environment. So let's do sys dot executable and reinstall torch transformers datasets. Okay, let me see. I am not in this. Where did it go? Let me restart the server. Okay. And let's run the Jupyter notebook again. Inside the source, inside the model train, this is the notebook. And let's run this. Already satisfied. And let's import this. Still that error. So let's try this. Pip3 install torch. Let me check with ChatGPT.
स्क्रब आया ना बॉडी स्क्रब इतना सेक्सी है ना मजा आ जाएगा लगा के कौन पकड़ा दो मांगा
It says I should confirm the path and also try restarting the kernel. Okay, let's see what path do I have. Okay, I don't understand a thing here. Okay, let's uninstall. Yeah, this works. Yeah, this works. Let's see. Yes. Okay, finally. Okay, so the normal pip command installs the packages in the root path or whatever you can say, and I need this python m command to install the you know packages in this specific environment. That's the problem that I think it is. And let's just wait for it to get installed. Let me remove all these cells. Yes. Delete. How do I delete this? C cell. Edit. Okay, basically, okay, I don't see the option here. Cut cell, copy, delete. Delete cells. Why does it say cells? Okay, delete cells. deep cells. Kernel is still running. Till then, just let me go over on this script for model training. It's going to take a while. Till then, just let me create the structure here. So our first, is it still running, right? Tell me it stops. Okay, okay, great, great. I think it's done. You will have package which is incompatible successfully. Okay. Let's see. Okay, no problem at all. We all have all these dependencies now. So our steps, let me just write down the steps first. So we are going to load and pre-process the data set, and after that we are going to uh, tokenize the data. Then we need to set the model training parameters, and now coming to the model training part, are going to load the tokenizer and a model, basically T5 model. Yeah. Then we are going to load and process the dataset. Actually, we are going to define the function here, and we are actually calling this function right here. Okay. Now just after that, we are going to split the data set to training, testing. Okay, then we are going to convert the data frame to Hugging Face dataset objects, which is the submitted format of the dataset for the Hugging Face models. Then we are going to tokenize the dataset, and after that we are going to be set up model training parameters, and we will define our trainer right here. Then we are going to do the train the model right here. Then we will save the model. Okay. Okay. So I repeated some of these. So okay. I don't need this. I don't need this either. And let's say we are going to write functions. Okay. So first, the function that we are going to write first is to pre-process the data. Okay. Let's turn this into code. Pre-process the data, and we are going to provide the data set path here. Then with open, we are going to open this data set path in read mode as file, and after that we are going to do uh, are going to import the data set as data, and we are going to json.load file, and just after that we are going to convert data set into Hugging Face format. Okay, so we need to turn this into data pairs, which is basically going to be a list which has an object of key input, and we will have this task as the input, and after that we will have output as we are going to use this to separate our outputs, and we are going to join the subtask description. So join subtask description, which is basically a subtask of this task. Okay, and we are going to do this for every subtask in task in the subtasks. Okay, and for this input, we are going to do for task in data. I hope this makes sense. Basically, we are looping over the data and we get this task here, and we are creating the input output format here, where we are going to put this task as the input, and in the output we join these subtasks, which is basically the description that contains the subtask. Okay, so in the task subtask we are looping over the subtask inside the task. Well, it is really getting confusing in the words, but yeah, it is really easy to understand here. Okay, moving on. We have created this data pair which is compatible in the Hugging Face model, and now we are going to return the data frame of the data pairs. Okay, right. Now we will define another function here, which is going to be tokenize data. So we are going to put our sample here, and we are going to create two variables which will contain the input and the output from the data frame. Now the source is going to be task plus source plus this token, which is marked as the end of the string. And after that, we are going to do the same for the target. We are going to put the target here and then mark the end of the string by this character. Now for the tokenized input, we will convert this input into tokens. So for that, we will use the tokenizer, and we are going to provide the source. Padding will be of max length, and set the truncation as true, and the max length that we are going to provide will be 512. Same for the tokenizer target. We are going to use the target here. Padding will be max length, and yeah, everything will be the same. Yeah, now that the data is tokenized, we are going to return this tokenized data as a dictionary. We will have this input IDs, which is basically our tokenized input and input IDs. Okay, and the attention mask will be tokenized input dot attention mask. And for the labels, we are going to be using tokenized target dot input IDs. Okay, invalid syntax. Oh, sorry. Yeah. So now let's come to the model training part, and let's see functions. And after that, we can say how this up. Okay. I can mention not parameters actually, configuration. I can say. Okay. So for the configuration of the model training, we will going to we need this. Uh, we need to set up a few things. First, this data set path, which is basically our raw data, not raw data actually, it was dataset.json, right? So it is going to be data log and then dataset.json. Then we define the name of the model on which we are going to be fine tuning our model. So as we discussed, we are going to use the T5 and we are going to be using T5 small for now. Okay, so the batch size is going to be 8 and epochs will be 3. The test size will be zero point 0.1, which means 10% for testing. Okay, this is the configuration. Now let's come to the model training part. So for the model training, we are going to load the tokenizer in the T5 model. So let's load the tokenizer, which is going to be the T5 tokenizer from pre-trained and the model name that we put up here. Okay, and the model is going to be T5 for conditional generation dot from pre-trained model name. Okay, let's see. Organizer requires sentence piece library not found in your environment. Okay, I need to install that. Sentence piece. Okay, let's add that here. Sentence piece. Let's run, restart and run. Yeah, installed. This is done. Okay, so now the tokenizer is set up and the model is also downloaded. Now we are going to be loading and pre-processing the data here. So it's just, we already defined the function. So let's do data frame and pre-process data and we use data set path here. Okay, let's run that. And let's see, data pairs is not defined. Let's see, data pairs. Yeah, should be data pair. Now let's run this. Great, no errors. Then let's split the data into two parts. So first we will have the training data frame and the testing data frame. And let's use this sorry, train train test split. Train test split here, which basically takes the data frame, our pre-processed data frame, and we are going to put up the test size here, which is going to be equal to the test size that we defined earlier, which is basically 0.1, and our random state is going to be 42, which I don't know what does. Okay, let's run this. Done. No error. That's a good sign. Now we need to convert the data frame to Hugging Face dataset object uh, finally prepare it finally prepare the data for the model training and testing. So we are going to put the training dataset here, and from dataset from pandas we put the training data frame here, and right, yeah, and similarly we are going to be do this for test dataset from test data frame. Okay, now let's tokenize the data set, like tokenize the uh, data sets, basically the training and testing data sets. Okay, yeah. So let's do tokenized train data set, train data set dot map tokenize data, and this is going to be patched. Same goes for, okay, let's see, tokenized train data set is equals to, and same goes for test dataset, train dataset map test. Okay, uh, test. Okay, let's see. It's like a very big error. Okay, so train dataset dot map tokenized data patched test dataset dot map tokenize, yeah, tokenized data. My bad. Okay, still the error is here, and let's see. can only concatenate str, not list. Okay, the problem is here at the source. Let's see. In the functions, in the source, we are getting task, the source plus that padding, and the sources sample input right to me. Yeah, this is supposed to be the string, right? Yeah, how is this a list but not a string? This output should be the string, right? Let's print the sample. Input is a list, and where is the output? Is the output? You can see the output. Yeah. So I might be having the issue here. We put in the input and then we put the output. What's wrong? Then we join it. Description for subtask in task subtasks task in data. So what's wrong? I just can't see the output. Let's do sample output. Let's see. Yeah, output is also here. Then what's wrong? Do I still get the error? Yeah, yeah, because this is a list, right? Not a string. We are putting the tokenized data, and the tokenized data is, okay, let's see where this come from. Tokenized train data set, and inside here we have data set actual function mismatch tokenized data sample, and where am I going to put the tokenization? Split the data, tokenize the data sets. Okay, so what is this tokenized data? Am I missing a step here or something? To put this as a list. Yeah. What if I just do this? Just a quick hack. Yeah. Just give me a few seconds. Let me see what's wrong. We do physics. Okay. And let me run this again. This was the error. Source. Okay, so do I need to convert this into strings or something? That's what ChatGPT asked me to do. Invalid. Is this going to fix the problem? Expected length 500 but got 1000. Yeah. Is there any discrepancy with the data or something? Just so this is happening because the uneven length of each string. So see, truncation is enabled, padding is also enabled. Then what's the issue? What is the issue then? Task source, that is right. That is also right. This is the max length, which is supposed to be 1000. Let's run this again. Yeah, after 4000, still that error. Expected length 500, but got 1000. First iteration, second, then third, then fourth, and then fifth. I Okay, so let's end today's live stream here. I will be back with the solution for this error tomorrow.